here we go today. This is the last bit of trigonometry ratios and applications. So here we're angles between planes and other problems. Alright, so the angles between planes bit here, we've used strategy before. Identify your triangles and use them to solve. Alright, so here we go with an example. For the cuboid shown in the diagram, find the angle between the plane AG and the plane ABEF. Alright, and then B, there's another two planes that they refer to. So let's have a look at the first one. Alright, so AG, so if I drew a line here to A to G, that's that orange one there. Hope it's orange, whoops, there it is, orange, yep. So coordinates, that's three-dimensional, so it's coming out of the page and into the page. Again, we've got that same issue that we've got three-dimensional object depicted on a two-dimensional. So to find the angle, and the other plane it's talking about, ABEF, is the base here, of course. So what we do is we would then drop this straight down to the base, and then what we need to do is we need to join up this point F back to point A. So we need to take this point F, join it back up to point A, and then the angle that we're referring to is this angle in here, and so that's theta. We'll call it theta. All right, so it's the easiest way is identify triangles, bring them out, but when we're talking about a plane is to use a line that runs down that plane. So the plane's a three-dimensional thing, goes in and out of the page, but this line AG is the key line and drops straight down to the other plane, the base, and then back there. And so we use those lines, and it's the angle between those lines that we're interested in. All right, so what I've got over here then is I've got very bad drawing. So if that's A, this is the theta down there, that's a right angle there, that's F, and up here was G, wasn't it? So that's G. All right, so what do we know? Well, we know this height here is A, and so what we need is we need this here. Now, we can find that there if we look at the base and take this bottom here, this base A and B. Now I'm looking straight down on top, E and F, and AF is that one there. Now, when we look at this, even though my diagram doesn't look like it, that's 3A, that's 3A. So it's actually square, but whether it's a square or whether it's not a square, we've got a right angle triangle there, and we can use our old friend Mr. Pythagoras, and he says that AF squared is equal to 3A squared plus 3A squared, so 9A squared plus 9A squared, which would be 18A squared. And so from that, when we square root to get AF, now 18 is 2 9s, so 3 root 2 A would be AF. All right, so now we've got AF there now. And so now we want theta. Now we've got the opposite and the adjacent, so it's tan theta equals the opposite, which is a, over the adjacent, which is 3 root 2a. And the good thing here is our a's cancel out. So we end up with 1 on 3 root 2. We'll then grab our calculator out and do theta is tan minus 1 of 1 on 3 root 2, which turns out to be 13.26 degrees when you figure that out. All right, the next one, part B, is a bit more trickier. So what I'm going to do is I'm going to get rid of these constructions that I've done, because I'm going to do some more constructions. How can I get rid of that? No, not like that. Oops, that's not what I want. Line, yes, get rid of that line, delete that line. Line of the line, let's delete that line. There you go, look at that, magnificent. All right, so the angle between the planes ACH, so ACH, so ACH and so if I then go from here down to here, that kind of completes that a little bit. So we got this kind of triangular shape. Now we want the angle between that and DCH. So DCH is this bit up the top. So let me have a look here. Line, borders, fills. Let's go red. All right, so DCH hasn't changed because it's the fill, and I'm not after the fill, I'm after the border. Oh, no, after the border there. And then back from there to there. So I've got these two triangles, all right? So I've got that triangle there and this triangle up here, and I want to know the angle between. Now, the side DA, I should say, well, I can make a triangle out of that. But we want the angle between these. So what I'm going to have to do is I'm going to have to, not running up there and running across there, because that's not up the middle of it. So what we need to do is we need to do this. And so I'm going to use the pen for this time. And so I'm going to use that. So if I go up the middle to here and then middle across there, then I've got, and I'll call this point, I'm going to call this point here, I'm going to call that point M. Now that point M is the midpoint, halfway between H and C, okay? And so that length there and that length there are the same. And the angle that we want is this one in here. All right, so this is a bit tricky, this one. But what do I know? I know this height here, I know is A. Now, if this is the midpoint between H and C, it's also the midpoint between D and G. Now, D and G are directly above A and F. A and F. and D and G. So we know what A and F is. So we would then know D and G. So let's have a look. This is the triangle that I'm looking at. So that's M, at that point there, D and A. So we've got D and A, and we know that height is A, and what we want to know is this. And so what we know is that DM is halfway between D and G. All right. And because the line DG is directly above the line AF, and we already know AF is this one here, so DM is a half of 3 root 2A. Half of that. So 3 on 2 root 2A. All right. Now, we know that. That's all right. That's good. Let me put that. So it's 3 root 2A on 2. There's another way of writing it. I'm going to write it that way. So which did we want? We wanted the angle between those planes. So this orange triangle and the red triangle. So the angle that we need is there. That one up there. So that's this one up here. This is alpha. Let's call it alpha. This one up here, call it alpha. And again, I've now got these two sides. So tan of alpha is the opposite over the adjacent. Now, if I'm dividing by a fraction, I'll turn it upside down and multiply. So let's get rid of that. Turn it upside down and multiply. So the A stays as it is. This is divide. That changes to multiply, and we flip it. So 2 on 3 root 2A. A's cancel. Leaving 2 over 3 root 2. Alrighty, so alpha then is 10 minus 1. 2 on 3 root 2. You grab your calculator out and you get 25.24 degrees. Alright, so they can be a little bit tricky, those ones. Particularly that first one, not too bad. But the second one, a bit tricky. So just got to be really careful with when you're identifying your triangles, which ones you're using, how you're using them. All right, and as I said, bring them out, draw them, bring them out, draw them, see what else you might need to need. Then look at what part of the diagram you can use to find what you need. All right, another example. So that's between planes. Here's another different sort of application. So a box contains 2 golf balls that snugly fit inside. The box is 85 long. Well, let me draw a box here. Let me go. All right, so here's my box. I'm just going to look at a side. Yep, that's not real good, is it? Fills. No, don't want a fill border. I need a border. Let's go. There we go. All right, so here we go. Here's my box. All right, so inside my box, I've got some balls. All right, 2 golf balls are sitting in there. I'm just going to draw them by hand. So I've got 2 golf balls sitting in here. Obviously, they're the little beautiful circles we've got there. And that's 85 millimeters long. All right, now, if there's a 3-dimensional kind of a diagram there, like so, here it would be, that's 85 millimeters long. And if it's 2 golf balls, well, it's too long. The height, of course, there is only 1 golf ball. All right, so 2 balls. So 2 balls is 85 millimeters. So the diameter of 1 ball is 85 divided by 2, which is 42.5. All right, and so the radius of the ball then, if we need to use it, which we will, is 42.5 divided by 2, which is 21.25. Not centimetres, millimetres. All right. Okay, so the question says, what percentage of the space inside the box is air? All right, so these bits around here, they're air around here. So what can we do? Well, what we can do is we can figure out the volume of the whole box. We can do that pretty easily because we now know that that's 42.5 there, and this is 42.5 at the height. We can work out that. We now know the radius of our ball, so we can work out the volume of that. So let's have a look. Excuse me. So the volume of the box. It's the length times the width times the height. Yeah, you grab your calculator out and you do that, and you get 15353.25 millimeters cubed, not squared, cubed. That's right. So volume of the golf balls. Volume of the golf balls. Remember, we've got 2 of those. So the volume of the balls. Two, because we've got 2 times two of them. All right. The volume of a sphere is 4/3 pi r cubed. All right. So that'd be on the formula sheet. I hope. 4/3 pi r cubed. Now r is 21.25. And you get your calculator out and you work that out, and that comes out to 80,388.77 millimeters cubed. All right, so the volume of the air would be the volume of the box minus the volume of the balls. So that's 153,531.25 minus 80,388 and 0.77. And when you figure that out in your calculator, you get 73,142.48. All right, so what we were asked in the end, percentage of space, so inside is air, so the percentage of the volume is air. All right, so the percentage of air is the volume of air over the volume of the box times 100, which is 73.142.48 over 153,531.25 times 100, and we get our trusty calculator out. and let it do the job, and you find that you've got a lot of air in there. 47.64% of the volume of the box is air. All right, so with those ones, I guess the strategy is you need to read, you need to draw some diagrams. I would not advise strongly against trying to visualize it in your head. Get something on paper, draw, diagram, even if it's rough. Doesn't need to be, rough diagrams like this do the job. So you can then figure out what you actually need to do. All right, so if you got anything you need clarifying in any of that, make sure you get it. And of course, have fun.